1.8, it's about classifying polygons. There's just a lot of language here. Not so much math for this lesson because it's about descriptions, okay? So a polygon, poly just means many sides, right? So we could have so the smallest polygon is a three-sided polygon, which is a triangle, right? We're going to do a lot of work on triangles as we go. But it's a closed plane figure formed by three or more segments that intersect only at their endpoints. So each segment that forms a polygon is a side of the polygon. Okay? The common endpoint of two sides is a vertex. So when two lines meet, like here in this, where two lines meet, that point they meet at is called a vertex. I got you. It's back. A segment that contains any two non-consecutive vertices. That means multiple vertexes. Is a, what is this? A side. It's side again. Okay. Now we get into what is probably new language maybe for you, but we talk about a polygon where everything's equal. All the sides are the same length. All the angles are the same inside of it. So that polygon is called a regular polygon with all sides equal. And same thing for the next line, a regular polygon with all angles equal. It's like a stop sign. That's a regular polygon. It's 8-sided, but all the sides are the same length and all those internal angles are the same. So if a problem says, this is a regular polygon, then you know that about that shape, that it's all equal. If it has both equilateral and equiangular, that's what those two go, that goes with these two. I'm sorry, she wrote that up there. Equilateral. That means all the sides are the same. And equiangular, that means all the angles are the same. If it's got those two things going on, then it is a, for sure, I'm hammering that home, regular polygon. Because half the problems you see about a polygon, it's going to say something in the directions. It's going to say, given the regular polygon A, B, C, D. That's a square. Because if it's got four points and it's a regular, all the sides are the same. 4 sides with everything equal is a square. A polygon is blank if any part of a diagonal contains points in the exterior of the polygon. It's supposed to say interior. That's my bad. And that guy is called concave. Like, can you still see that in this picture right here? This picture is a concave polygon because look at that point. It's inside. If you turned that upside down and poured water over it, it would hold water right there. That makes it concave, like a bear lives in the cave, if it'll hold water. Then you've got this kind of polygon where all the points are to the outside. If no points are in the, it's supposed to say no diagonal contains points in the exterior, then the polygon is convex. And you should know that a regular polygon is always convex. So, convex, right here where my finger is at on that screen, that all those points, that would not hold water no matter how you turn it and poured water over it, it wouldn't hold water. This one, if you turned it up like that, that would hold water right here. if you poured water over it. This one would. You see how these lines cross each other inside that polygon? That's not a polygon. So I want you to see that. That's not a polygon because of this cross. This is not a polygon because that side is curved. This is not a polygon because it's not closed. It has to be completely closed. It's open right here. So that keeps that from being a polygon. All of these others are polygons. This is even a polygon. Look here. This is a polygon where these little tick marks, you know what those mean? Anybody? They mean all the sides are the same. That's right. So that's what those mean. And if they got tick marks and these little arcs in the corner, that means all the sides are the same and all the angles are the same. Like this last one on the page. Okay? We are 6 minutes in. Flip your paper. Let's name some polygons.
Triangle.
The first one, triangle.
Okay.
3 sides, always triangle. 4 sides. What's the generic name for a 4-sided figure?
Square.
Nope. Quadrilateral.
Okay.
Yep. How about a 5-sided square? We got a government building that's named that. The Pentagon.
Yeah, that's the only thing I know.
That's good.
It is called a
6-sided hexagon.
Everybody know a little.
7-sided. This is not a common one, so it doesn't surprise me. Heptagon. You've heard of it? 8-sided, like stop sign, is a octagon. Octa. 9-sided. Not common either, but it's called a nonagon.
The next one is a decagon.
Very good. 10 is for deca. That's
Dick.
how about 11-sided?
And decagon.
Not common at all. An 11-sided figure is called a dodecagon.
The 12th one is dodecagon too.
Is it?
Yeah. Look it up.
It might be wrong. But here's what's important. After this right here, after that mark right there, you call things n-gon.
Yeah.
So like
That's what he said. Something like decagon.
12-gon. 13, if it's a 13-sided figure, you'd name it a 13-gon. And that's how you'll read it too. When it says, look at the figure below, it's a 15-gon. That means it's got 15 sides. Okay? So after 10, the main thing here is to remember that the n-gon, whatever number's out in front of that, that's how many sides it has. In geometry, perimeter can be defined as the path or boundary that surrounds an object or a shape, whatever you want to call it. It can also be defined as the boundary, the border of the outline of a shape. So here's the typical math problem for this lesson, okay? If I tell you that a table is shaped like a regular hexagon, tell me what regular means. All the sides are what? Same. Tell me what a hexagon, how many sides does a hexagon have?
6.
Hexagon, 6. Okay? I'm sorry that this has, hey, shh. Let's do one shape right here. Mark that out. It shouldn't have that at the bottom. And if I ask you to find the perimeter of this hexagon, you've got 6 sides that are 3x plus 6. Do you see that? Now, we're not going to be able to find a number unless we know what x stands for, right? But we can find an expression using the distributive property. 6 times 3 is 18x. And 6 times positive 6 is 36. So the perimeter can be equal to an expression. Then I can come back and say, well, if x is 5, how long is each side? You know, or if x is 10, what's the perimeter all the way around the thing? But this is the hardest math of it, which is this distributive property from algebra. And it's all based upon that this shape in the problem, it says it's regular, which means all the sides are the same, and it's a hexagon, which means it has 6 sides. That's why you got to know those words. And that's it, guys. The practice for this is really not hard. You're going to identify polygons, tell whether it is a polygon or is not at the first, and convex or concave. And then on number 5, that's a multiple choice question. 6, 7, 8, 9, 10, 11, you're just classifying, which means you're naming polygons. And then 12, 13, and 14 are about regular polygons with expressions given for 2 side lengths. Find the value of x. If this guy's regular, what do I know about these 2 sides? What do I know about them?
They're equal.
They're equal. What do I know about these 2 sides on number 13? They're what? Equal. How about these 2 sides over here? Equal. So you can just set up equations with those equal to each other and solve for x. Okay? Yay. Is there a back to this? There's not. That's the end of it.